This is a discussion on Gustav Eiffel, man of iron and air. Gustav Eiffel is generally known for his Eiffel Tower in Paris and for the internal structure of the Statue of Liberty in the Hudson River in New York. However, less known is the fact that during the last 21 years of his life, Eiffel began a new career as an applied scientist in the field of aerodynamics. He essentially went cold turkey into that area. Beginning in 1903, he conducted experiments to test wind drag on objects dropped from the second floor of his famous tower. By 1909, he had also built his first wind tunnel at the base of the Eiffel Tower. He went on to become France's leading aerodynamicist at the time, mainly on the basis of two important wind tunnels that he designed and built just south of Paris in 1912. With his wind tunnels, Eiffel made 7 substantial contributions. First, the design itself of his wind tunnel was pioneering and new. It consisted of a convergent nozzle, an open jet in a hermetically sealed test section, a divergent diffuser, and a fan that sucked the air directly to the atmosphere. This design became known as the Eiffel-type wind tunnel, and it's still used today. Eiffel successfully proved the viability of what today we call the wind tunnel principle, which states, quote, "The same force is made by the thing against the air is made by the air against the thing." This was first stated at the end of the 15th century by Leonardo da Vinci. That's why it's in quotes. Eiffel obtained proof by dropping a model of an aerodynamic shape from the Eiffel Tower and testing the same shape in his wind tunnel. He wrote, quote, "The concordance between the results obtained by the two methods shows that a surface moving through still air offers the same resistance as a similar surface held stationary in a wind." He was also the first to make detailed measurements of the pressure distribution over the surface of an aerodynamic shape. He proved that the net lift on a body in a flow is the integrated effect of the pressure distribution over its surface. He wrote, quote, "The summation of the observed pressures was equal in every case to the reaction weighed on the balance." He conclusively proved that the majority of the lift on a wing is derived not from the higher pressure on the bottom of the wing, but rather from the lower pressure existing over the top of the wing. He conducted the first wind tunnel test that used scaled-down models of complete airplanes, not just wings or models of fuselages or individual components like that. He coined the expression wind tunnel that we use today. Earlier investigators used the terms artificial current and delivery tube. The Wright brothers had merely called their wind tunnel the apparatus. Eiffel also coined the expression polar diagram to refer to the graph of lift coefficient versus drag coefficient. Both wind tunnel and polar diagram are concepts used every day in aerodynamics. By 1912, some of Eiffel's experiments were considered classical and were included in a new course being taught by French universities. Eiffel died on December 27, 1923, but his 2-meter diameter wind tunnel remained in use for over 100 years. His work provided a powerful springboard for applied aerodynamics in the 20th century.